Hey guys, I just wanted to show you my quick progress on the solar tracker. What I have so far is I have this board with 4 components on it, 2 photoresistors and 2 10K resistors. That's then going to the Arduino de Millenove, and that's then sending it to a continuous servo right here. And what it does is it takes the voltage between these 2 photoresistors, which is affected by light, as you can see here. It then sends that signal through the board and then tells the continuous servo what direction to spin. And what it does here is I have a left and a right. And as you can see here with this flashlight I have, if I shine light on the right photoresistor, that'll actually cause the servo to spin in one direction. If I come over here and shine on the other photoresistor, you can see that it's spinning in the opposite direction. And if I can kind of get close enough to the center, it'll actually cause the servo to sit still. And that doesn't seem too useful right now, but what it actually will do is, if you can imagine this board with these components sitting on top of this spinning servo, what it'll do is it'll actually cause the board to spin and thus the sensors to spin. And what will happen is the sensors will always point themselves towards the brightest source. It'll spin until the light source hitting the two are equal, and then it'll stop spinning. So one of the main advantages of this system is obviously the little number of components you need. Right now on this board I have only 4 components. I have the 2 photoresistors, and for every resistor I need a drop voltage resistor. I'm using a 10K, as you can see here. I think right now we'll switch over and see what the code looks like. Alright, I also wanted to share with you what the program looks like on the computer side. The first thing I always do is I always include a header, and I always include the name of the program, what the program does, and when it was created, and my name, or whoever created it. The header is always commented out with these symbols right here, which signify a block comment. Anything I type in here will not affect the program at all, and the compiler will not read this. So I can type any words I want, for example. A next thing I always do is I always include my libraries. In this example, I'm using the servo.h library. There's also a math library and hundreds of other libraries you can use. Next thing I always do is I always include all of my variables. These are all integers, so they're all whole numbers, no decimals, no fractions. They're all global variables, which means they apply to all of the functions. I do this all together to make it easier to see where the numbers are, instead of going through and changing whichever pin I use on my board. I can always just go up here and change that pin to number 9, and it'll follow through all the way through the code. So I have servo out, pins right and left, left reading, right reading, the position of the servo, and a tolerance value. After this, I always have, I also initiate my servos. So I just have the servo and then the name of my servo, which is, it can be anything you want. I have mine as my servo. Next is the first function. The void setup is the name of the function that the Arduino uses to set up the board itself. So the first thing I want to do is tell it that the servo is connected to servo out pin using the servo.attach servo out, which I assigned as pin 9. I also have serial begin at 4600. What this does is it initiates the serial monitor, and the 4600 is the baud rate that we're linking to. After the setup function, we go to the loop function, which is where all the work happens. Once this function is done, it'll come down here and it'll loop all the way back up and start all over again until we cut the power or upload something else. Left reading equals analog reading photo pin left. So what this does is it takes the voltage reading at the analog pin and assigns it to this variable left reading. Same thing for the right reading. I then take this left and right reading and I send it to the serial port. and you can see I have it labeled left reading and then the number left reading. So once you look into the serial monitor, you'll just see these functions flashing up and down so you can uh, see and debug what's happening. After that, I then use a selection statement and I compare the left and the right readings, and plus I add my tolerance in there. What the tolerance says is the plus or minus value. Um, the two numbers are never ever going to be exact because there's always variations in your components. So what you have to do is add a tolerance value. So I did this here using a tolerance, which I defined up here again as being 10. What this does is it says if the left reading or the left photoresistor has a higher reading than the left, I want the servo to spin in one direction, and I have that set to 60. I'll show you how to set servo numbers later. I set the opposite true using this else if left reading plus tolerance is less than the right reading, I want it to spin in the opposite direction, so I set it to 45. And else, which would be if left reading and right reading are within the tolerance and they're close enough that they're sort of matching, I have it set to 55, which will make the servo sit still. I then write this position, the 55, 45, or 65, to the servo using the myservo.write function, and then I delay it 120 milliseconds. If there's any questions, you can go ahead and leave a comment. I'll be sure to answer as much as I can. Thank you very much.